Hello, welcome back to the channel. Today we have a Vector 8800 with an alarm. Customer complains that it's shutting down. They didn't really say what the alarm was, so we're going to check it out. So here we are. We'll fire it up. See what she says. Might be kind of loud. I'm right next to a rail. San Jose, California. Inactive alarms in memory. We'll get to that maybe. We'll see what she does. Do unit operations first. Unit's got 675 total switch on hours. Unit's fairly new. Let's see here. Yeah, it's new. Alright. You guys haven't seen the new 2.4 liter. Here she is. Check at next service interval. Oh, there she goes. Alarm shut down. Check condenser con relay coil 2. Condenser motor overheated. Alright, so I'm going to get some things opened up here and get some test points on, and then we'll jump into it and show you how I diagnose this. Be back. Okay, I'm back. So I opened up some panels, took a door off, so we can do a diagnostic. Just make it real quick. So as I took off the curbside door, and then I went ahead and loosened the PCM, just the 4 bolts. I removed the door latch mount, and I back pinned. This is the PCM control module, so power control module, and I have a back probe in the pin here, if you can see it there. Okay, so you got 35, 34, 33, pin 32, and I'll show you why I'm going to be testing there. I don't have the lead connected, it's just sitting here. Up here you have your, you probably can't see it, it's up here, that white plug there. That's your condenser fan 2 motor plug, and we're going to check that in a minute. And then of course here you have your contactors. I'll do a unit identification video if somebody requests it. These videos are more based for the newcomer to this career and to people who are just wanting to learn and want some troubleshooting, you know, ideas and stuff. I'm not perfect, and I definitely don't do everything 100% right, but I try. We're going to go ahead and put the unit in component test mode. I'm going to show you how to do that. But first, what we're going to do is we're going to go over to my laptop here, and we're going to look up a circuit diagram for this Vector. And that's my beautiful baby girl there. And I have a drive there that I put together, and I have a lot of stuff on it. Every manual, every book. It's took me a lot of time. Go to trailer here, carrier trailer, and we're gonna go to service books. And I'm gonna go. This is an 8800, but we're gonna go to the 8700. It's a lot easier to see for single schematic since we're diagnosing just the primary compartment. So if you see right here, I have Vector 8700 SW8 platform, and like you see, I've been here before. This is the low voltage schematic, and what we're mainly going to do is we're going to look and see here where and what the condenser fan contactor needs to operate. So if you look down here, it's kind of hard to do this with the phone in my hand. So here's our condenser fan motor 2 IP circuit, which is what we're going to check first. I always check those first. So here's our contactor, pin A and A2. A2, you can follow it here, see where it goes, along with A2 goes up this way, and you follow it goes to ground here. So we're not going to worry about that. Well, we know A2 goes to ground. And then of course SP42 is going to go to power module 34. We're not going to worry about that at this moment. But what we are trying to focus on is right here. the condenser fan motor IP circuit. Okay, and if you look, oh, I grabbed the wrong pin. It's on PCM 31. So let me fix the back probe, and then we're going to put it in component test mode, and we're going to check and see what's going on with our contactor in the meantime. So stay tuned. Okay, I'm back now. So here we go. We're going to go ahead and do this diagnostic here. So I took the cover off so you can see the contactors. This is condenser 2, condenser 1. Okay. So what we're going to do is I'm going to go ahead and cancel out of it here. I already went into it prior to this. So what we're going to do is we're going to put the microprocessor in an output test mode where it can actually help you troubleshoot circuits that are giving you issues. So sorry about the sun. It's kind of in a bad spot. Okay, so we're going to go to menu and press it again. Hopefully you guys can see this. This is pretty bad. And we're going to go to tech mode right here. And we're going to go ahead and go to component test mode there. See it there? Okay. Now to get to component test mode, you have to put advanced user mode in. Then you have to put in tech mode. There is a password. Since I was already prior into it, I went past the password. That's something we'll talk about later. But for now, this is just for the means of the video. The password is 7435. Waiting. Okay, here we go. So we're going to go ahead and scroll down to the condenser contactor right there. Condenser motor contactor number 2. And we enabled it. If you notice, here we go. We're talking about amps again today. It only is pulling a half an amp, 500 milliamps, which is not enough. So what we're going to do is put our meter to 12 volt DC. And we're going to test across A1 and A2. Now there should be voltage there. Let's see if I can do this. So there we are. And we got nothing. So now we can check to see if maybe we have a defective ground by just going from ground. So we'll go to the PE plate here. Okay, it's right there. And we're going to go ahead and go to A2. See if I can do it with one hand. And nothing. And if we go to A1, no voltage. So if we go to continuity, if you want to check the ground, we'll go there. We'll do the same test. So PE plate to A2. You hear it beeping, I hope. So we have continuity to ground. So now what we're going to do is we're going to go back to the diagram over here. And if you notice, we were checking this circuit. So we have ground, but we don't have any voltage here. So we're going to go ahead and just jump all the way to pin 31 and see if we have a voltage output. Now, if you look here, this is a high side number 6, 2 amp internal. You can't fix that, but you have the big fuse here. Now, if that fuse was blown, none of this circuit would work. So, meaning there would be a lot of other alarms. So we're going to go ahead and check condenser fan motor 2. Pin 31 for voltage, okay? So now we're going to go back over here and we're going to verify we're in output test mode. We're going to cancel it and then we're going to go ahead and go right back into it again, okay? Grab my meter that I dropped. And you can see over here I got it pinned to the correct pin this time, which is 31. And we're going to go to the trusty old fluke here and remove my ground lead. I'm going to be getting a chest camera soon, guys, so I'm sorry. Actually, we're going to put the ground lead back. I'm doing this live. This isn't one of those videos that are set up or any of that. I've seen a couple of those on YouTube. I was like, oh, wow. So, remove the positive. And if you see here, pin 31, and it says it on the back of the plug, we're going to plug in our meter here, like that, okay? So now all I got to do is go right to battery ground with the output test mode on, and if we have voltage here, we're doing something. 12.8. Okay. I did reference the battery earlier. It was at 12.8, 12.85. So that means our voltage coming out of here is good. So that means between here and up here where the white plug is, we may not have a connection because we don't have nothing coming from pin 31 all the way over to the box over there. Okay, so I'm gonna go ahead and unplug that, and we're gonna check for voltage at the condenser fan motor plug there. Be back. Okay, so we're back, and what I did was I got an alligator clip put on my lead because I'm watching you guys, helping you guys on the ground of the battery. Got the fluke up here. We're set on DC voltage. I have the plug unplugged there. Okay, and what we're going to do is we're going to check the pin coming in for voltage, which is this guy right here. And we do. So if you look here, I don't know if you can see this, it's kind of hard to show you with the phone. I'm checking the IP circuit, which is the two white wires there. That's the circuit we looked at on the diagram. So voltage has to come into this plug, voltage has to come into this plug, it has to make continuity, into the fan IP circuit, which has a positive thermal coefficient resistor in it, meaning the hotter it gets, the higher resistance it gets, and that makes the circuit literally look like open, but it's not. So, and then once it comes back down from the fan, it connects the circuit, which connects to our contactor. So if the fan overheats or gets a stick in it or who knows what, drivers kind of do some crazy stuff sometimes, it will cause the fan motor to get hot. And once it gets hot, that resistor that's built into the windings on the fan, I'm not going to get all crazy about that part, as it gets hotter, the resistance increases. And as the resistance increases, it creates so much resistance that it makes the wire look like an open. And we all know on wiring there's three things that can be wrong. You can have a short to ground, an open, which is a disconnected broken wire, or high resistance. So we're going to go ahead now and check the ohms on this fan to see if our IP circuit is open. So let me get all set up here. Give me 1 second. So now that I've got it to ohms now, okay, because we're measuring resistance, and you can see I'm in the IP circuit there. Got the two white wires on the top, and I'm checking across the IP circuit, and I have over limit, meaning that there's zero continuity going through that fan motor as far as the IP circuit goes. And if I take my leads here and I touch them together, see that? We have infinite resistance. So that fan motor, the IP circuit in the fan motor, is considered defective or faulty. Now, to double check that, we're going to go ahead and come back over here. We're going to exit our test mode. We're going to go back in one more time, and I'm going to do something that kind of helps make diagnostics a little bit easier. And what I'm going to do, since I know my fan circuit is open, I'm going to go ahead and I'm going to jump the connection with these guys right here and just see if my contactor energizes. So right here, the IP circuit there, okay? And I'm gonna go ahead and jump it. Oh, you guys probably can't hear it. Maybe you can. But by me doing that, I can hear the contactor engaging. Now, I don't recommend you do this to bypass the fan or anything like that, because that can cause a lot of problems and shorts and fireworks. So we know now with our diagnostic here that we have a defective condenser fan motor, the IP circuit side, not the voltage side. So when I'm going to change the fan, I don't have one on the truck today, so I'm going to have to return as a follow-up. But yeah, there you go. And that's how you diagnose that particular alarm in that aspect. So there's other aspects to this alarm, and I hope people don't just jump to this right away when they have an issue with the condenser fan alarm. One other thing I didn't go over with, and that's something you should just do, is check your timed fuses, and you just check it with continuity with your meter across here with ohms, and you should have resistance. Now this has two compartments, so these fuses here, this is the second compartment, will have fuses in it. Some of them will, some of them won't. If they don't have a second compartment, there will be no time fuses in here, and if there is, you need to remove them. If there is a second compartment, then of course don't remove them. But you have your heater strips here, you have your battery charger here, and then you have your 3 fan fuses here, which is tied to all 3 fans. So the 2 condenser fans and the evaporator fan circuit, 1 per leg. So I hope this video was helpful. Have any questions or anything you need to know or comments, good or bad? I'm sure there's people out there that are going to hate. They always do. Just let me know, leave it in the comments, and I'll try to continue making more videos. Peace. Okay, I wanted to iterate on some things today. One, just a brief overview of what we did. This video is kind of long, but it's worth it. So we had an alarm, a condenser fan motor overheated. We put the unit in component test mode. We checked the contactor across A1 and A2. We checked the power output coming from the power control module. We had voltage coming out. We checked the voltage at the fan plug. We ended up testing the continuity of resistance for the IP circuit on the fan, and the fan had it open or high resistance in the coefficient sensor, meaning the condenser fan was defective. There are other testing that you could have done or different ways. I just wanted to iterate kind of what's going on, but mainly what this was about, I just got back to the shop. I wanted to talk about high voltage, and I wanted to let you guys know, please practice safely with high voltage. It can kill you. It's very dangerous. If you're new around anything above DC 12 volt, please either have somebody standing next to you or do some research, do some reading. Wear safety equipment. Wear protective electrical gloves. Wear safety glasses, rubber-soled boots. Always test with the high voltage disconnected or off. Generator not spinning, meaning motor not on. All the stuff on these units you can test with the unit off. You can check continuity, you can check resistance, you can check several things with a multimeter. A mega ohm meter is used to test internal windings on anything with high voltage. You can even do low voltage, but we're not going to go into that. But what I'm trying to stress to you is that all this stuff can be done with the unit off. You don't need it running to check to see what's going on. There are some testing you can do live, and you can do it safely and practice it safely. So stay safe out there and keep reefing. Keep it good. Talk to you later.